Hello everyone and welcome to Handmade Hero Show. We code a complete game live on stream. I yesterday did some code that can load and dump our asset files, and I want to also make something today which allows us to rewrite them so that anytime we want to change versions or how they're laid out or optimize them or remove things or do anything we really want, it's not a huge deal. We can just do it. And that's just kind of a nice thing. I felt like it was worth showing how to do that because it's not that hard, as you've seen. It only takes a couple hours to build something like that. If you remember correctly, that's our HHA edit program, which is this program right here. And at the end of yesterday's stream, we were taking a look at the dumps there. And I was using tab view for that, but you can really use anything you want to view those things. Where did I put that? It's in the bonus pack. So here's tab view, right? And if I go ahead and take a look at some of the file dumps that we had, you can sort of see where we were going with that. Here is the data directory. Here's the test fonts, for example. Here's a dump of the test fonts HHA file. And what you can see here is, we've got a bunch of glyph bitmaps in here. You can see them fairly straightforward, right? Everything you would expect. And, it's also got the font information, things like the descenders, what the tags were for the font, and all that sort of stuff. So that gives us good confidence. The main reason I wanted that was that just gives us some nice confidence that we're loading everything properly. And now if I want to resave this file using the same code, it should be fairly straightforward to do so, right? Because now we know we've got this loaded HHA here that has imported all of the data from the v0 file, which means that now it's pretty easy for us to write out a different kind of file because we just iterate over this, and then it doesn't matter whether we loaded a v0 or a v1 file, right? It doesn't matter which kind we did. So if I then take a look here at the write HHA, you can see here we got the read HHA and the write HHA. So if I just make a thing here that allows me to write out the version of the file, HHA v1, let's say like that, and I pass it a dest file, what I need to do here is pass it something to take as the source, and of course we already did the command line necessary to load that in. I think we've got a rewrite command, right? That we, doesn't really do anything right now, but you can see we make the calls, right? It just doesn't do anything. So if we take a look at write HHA here, you can see that, we're all set up to go. We've opened a file for writing. So the only thing we really need to do now is actually write something that does this output of the loaded HHA out into a destination file, writing it sequentially. And so that's all we need to do. Again, not particularly difficult. All right. So really all we need to do to write one of these HHA files is place the header information. We know exactly how big the header is going to be because it's a fixed size once we know our asset count and our tag count, both of which we know. So if we just leave the space for the header, and this is the same thing we did when we originally wrote HHA files, if we just leave space for the header, all we have to do is loop over everything we've got, dump it all out into a big old mush, and as we go, every time we write out a piece of flexibly sized data, all we have to do is just remember where we wrote it by putting it into our version of the header that we're going to save. Then at the very end, when we're all done, we just write out that header and we've completed writing the file. That's really all there is to it. It's pretty basic. Now, it's not always so easy to write something like that for the simple reason that it's a lot of finicky byte manipulation kind of stuff, right? So all of our byte offsets that we write to tell you where things are have to be correct. So, maybe we can get some of those wrong or something like this. But usually, if you're careful, it's really not a particularly big deal to verify them eventually, right? Okay. So what I'm going to do is I'm going to start by just doing the basics. I'm going to say, all right, we've got a dest file pointer. And I want to first move that pointer to a place where I can start writing my my data information, right? My what's the word I'm looking for? My I want to be writing my flexible data store, like the parts that come from bitmaps and strings and things that are just flexibly sized, that are not like those even chunks, right? That's what I want to do. I want to be able to just write those out. And one of the things that I honestly cannot quite remember is I don't recall how we were doing appending. Can we quickly look at that? How did we do that? Oh, right. We did that because these are relocatable. So we just relocate them. Yeah. All right. So basically, yeah, we don't really have to think about anything other than what I just said. It's really pretty straightforward. So this should be pretty simple. So let's go ahead and open up the file formats we've got here. So here's the header file. I'm sorry, the header data. So I'm going to first clear it because we want to make sure all the reserved fields are set to 0 so that if we want to in the future, we can look for optional things that we add there. So for example, let's say in the future we want to add a new array, a foo array. We want to put a 0 in there for all existing files to make sure that we know there is no foo array in those files. That way we don't have to bump the version number to add new things. We only have to bump the version number if we change the layout. So it just makes it a little bit easier to maintain a binary file format, right? It's sort of like a little bit of a halfway. So, you know, if you're going to have a binary file format, you're going to have a text file format. The bonus of a binary file format, very easy to load, it's quick, there's no fuss, etc. But because there is no parser, it's hard to insert new things into it because nobody's checking for anything, right? You just load and go. So in a text file format, the opposite is true. It's very slow, laborious, very error prone, but you've got this parser there doing all this parsing. It's easy to throw new things into it because you can just look for a new symbol. If you see it, you process it. If you don't, you don't, right? Well, zeros are a way of kind of inserting half and half into like a binary file format. Inserting a 0 point, like a bunch of unused 0 pointers, is kind of like saying there's a bunch of symbols we could use here in a text parser, right? It's a bunch of options you're leaving for your future self to use. So it's kind of a nice little halfway. It's like it doesn't suffer all the drawbacks of moving to a fully text file format, which, you know, would then have lots of options, but it also doesn't lock you down like a completely specified binary file format would, where you can't add anything at all without breaking something, right? So it's, you know, there's degrees, it's a continuum between binary and text, and you can kind of float to a position that makes you happy in that sense, right? So I'm going to go ahead and specify the magic value. I'm going to specify the version that we're writing here, and then I need to specify the other things we've got, like the tag count and the asset count. And these, of course, are known to us because when we loaded, we remembered all of these things, so we can easily do them here. We then have three things we don't know where they are: the tag array, asset array, and the annotations array. So, you know, at the moment, we don't really want to deal with that yet. So I'm just not going to, right? Like, I'm not going to do that. However, I am going to do some things to prepare. So I'm going to get ready to have written these things. So what I want to do is I want to first make the dest tags. I want to make the dest assets. And I want to make the dest annotations. And what I'm doing here is just preparing space because I know I'm going to write these things. And rather than do them after I write all the flexible data, I want the arrays around first, because those arrays are what I'm going to use to store where I wrote everything, right? So yeah, that's just how that goes. So what I'm going to do here is I'm just going to malloc space for each of these things. And what I'm going to do is I'm going to compute their sizes ahead of time. right? So I'm going to say dest tags size, dest assets size, and dest annotations. Oops. Annotations size, like so. So I'm going to figure out how big each of these should be. And of course, it's really simple to do because we kind of know already exactly how it's going to go. We know that each of these arrays stores something of this size, and we know how many of each there are. So we know that we're going to be using the tag count. Maybe I'll do it this way instead. We know that we're going to be doing the tag count for the tags, and we know that the assets and annotations, those are both going to come from however many assets there are, because there's one annotation per asset, assuming that that array is present. Which in the future, we can actually do a thing where we don't put that array in if we want to strip it out. We're just saying that's possible if we wanted to save space file. I don't think it's ever going to matter, but you could, right? Okay, so assuming that you've got this set up now, what we can do is just pass these sizes in so we know that that's how many we have, like so. And once we've got those arrays ready, we know that we can now store all of our information in them. So when we do our for I loops here over the tags and the assets, we can, do exactly what we want to do there, which is store where we wrote everything and other stuff like this. But then when we get to the end, now is when we would finally write them out. Now, how am I going to write them out? Well, one of the things that I think is important to remember is all of the things that we're writing kind of take the same form. They are something that has a particular size. So we know we're going to write out a block. And then somebody, somewhere, wants to know where we wrote it. So for example, when we write out the dest tags array, we know that the header wants to put those tags into the array, right? And so what we're going to do is we're going to put where we wrote it into here. That naturally informs what the API should look like for writing this file, because we know that what we're going to do is something that looks like this, right? We know we've got dest tag size here. We know that we've got the pointer to it. We know we've got the assets here. Oops, dest size, dest assets. And we know we got the annotations. Dest annotations size, dest annotations. And like I said, this is optional. So if we wanted to, we could do something like include annotations equals true, and test, like this. And so this actually is pretty easy for us to do. Now, obviously, it can't write to a file without knowing what the file is. It's that dest file there. So I can do this if I want to, and just complete the API. It's going to be pretty clear what it would be, like so, right? And so if I just use this write block function, it should be pretty straightforward for me to complete everything that I wanted to do, okay? So similarly now, if I'm up here with my for I loops, I can just finish everything off. Let's suppose that I want to write all of the tags first. So here's the tag index. I'm going to loop over all of the tags. And what I'm going to do is take the dest tag, and I now also want the source tag. And once I have these two, I know that I'm just going to copy the dest tag. I'm just going to take the source tag and copy it into the dest tag. Now, we know there's nothing else to do. It's just two flat values. So this is pretty straightforward. That's basically it. It doesn't need to write any blocks. It doesn't need to allocate any space. So this array is very simple right now. If the tag structure got more complicated, we would put the logic in here, but at the moment it isn't, so it just stays simple. So all of our logic basically comes in the form of the asset processing. So in here, as I loop over the asset indices, what I want to do is gather all of the information that I might need. So the first thing I need is the source asset. I also need the annotation, and I really need, I guess, this. And then finally, I need the destination asset and destination annotation that I'm writing, right? So I got the two sources, now I have the two destinations. Right? This is not what I meant to do. That's what I meant to do. There we go. So this sets us up to start writing the assets, but now we have to actually figure out how we're actually going to do that. So if we look down here, here's our HHA asset. We know we can copy this directly, and some of the things will work. All of this stuff is correct. That's right. These are right. These two things are not, right? Well, I guess the size is. The offset is going to change, right? Because it could be at a different location in this file than it was in the original file, especially if we start doing things like merges or whatever. And we may need to support a little bit more, like if we did a merge, one thing that you'll notice here is, for example, when we have this data store pointer, all of this stuff is off of the data store pointer, and that doesn't really help. So, you know, one thing we could do here is change sort of the way we're doing this data store a little bit to make it more flexible. Now, I'm not going to do that yet. I'm just going to kind of leave that for a moment. But this is something that I think we can come back to and make better than it is right now. And we can sort of see how we might do that a little later on, right? Okay. But at the moment, for just rewriting the files, when we load this stuff in here, we can still use the data store as it is. So the way that we need to use the data store is that's how we can figure out what the asset data actually consists of, right? So what we want to do here is say, okay, let's write out this block. We know we've got a source asset. We know we've got a dest asset. We can start by copying all the fields over because we know that most of them apply. But then we have to kind of ping back and take a look. Okay, so the data assets, the data offset is going to be wrong. So we can take the data offset and say, well, we know that the data offset for this file is going to be whatever the result of the write block is when we write this out. So what we could say is, all right, when we write this block out, go ahead and say whatever the dest asset data size is, whatever that size is, that's how much we're going to write out. We know that the dest annotations, we know that the location of it is going to be that data store, so the source data store, plus whatever the old original offset was, right? Because that's telling us where it was in the data store. So the source assets, data offset, offset from the data store, that's where the original block of data was, and then we can just append that to our file. So that copies the data out of the in-memory block we loaded when we loaded the file out into the new file, so now it's been written, and we store where it was written. That's really all we need to do for the asset. It's the annotations that create more of a problem. Those are fairly extensive here, and so we need to do a lot more work to write those out. So here we have our dest annotation that we need to fill out. So effectively, what we're looking at is a big kind of giant, just go ahead and prep this, a big sort of thing that looks like this. We don't need, to set the zeros on these reserveds, because what we could do is just zero the entire array. In fact, that's what we should do. Let me do that here. Well, that's actually already going to happen now I think about it. So it's really only the annotation we need. So I can just do this. Clear the whole annotation out, and then we just set the parts that we actually care about. Oops. Got a little overzealous there. So in here, we know that we've got kind of a number of different sorts of things we're storing. So let's take a look. First of all, we know that a bunch of them just come from the source annotation. So for the ones that come from the source annotation, we've got a pretty easy job, right? Those just get copied directly in. So things like the sprite sheet and the source file date, like that sort of stuff, right? Oops. Source file date, source file checksum. Oh, you know what? I guess these reserves kind of have to be copied as well, right? So never mind. I guess we will actually do those. I didn't really think of it that way. I should have thought of it that way because we want to copy reserves over. Even if we don't know what they are, we want to preserve them, right? Probably. I don't know that we necessarily can. It may be a fool's errand to bother. So it may be that we actually want to strip. Now that I think about it, we probably just want to strip them out. Yeah, we probably just want to strip them out because assuming that they referred to something that was like an offset in the file or something, we can't preserve that. There's no way to preserve that information. So that, yeah, that doesn't actually work. So never mind. We won't be doing that. So what we want to do now is actually write these the information here about the file, right? So base name is base name where's the base name count? Source file base name count. We accidentally deleted that, and I apologize. So there it is. So there we go. So basically what this boils down to is a series of us writing these things out, like so, right? So we copy these things like this, and then we effectively have to write some strings out that come from actual like C string style stuff we've got here. So again, we pretty much just know what these are though, so it's not particularly hard for us to do. And furthermore, we can probably just make this a bit of a utility here. We could say something like write string, and then include the count field as an address for it to fill out. So this can be something that's fairly automated for us. We just say, look, source file base name is a string, write the string, stick the count in here, and that's, you know, have a little party, right? Like so. So that's something we could easily do and probably should, and you know, and did. Now, yeah, this is a little bit kind of annoying to copy, but let's do it anyway. So let's do that. Here we go. And now I just have to change these to be the correct things. So I want to do author name offset here. Author name count. And this one is asset description offset. Asset description count. And you know, we could make utility for this. Like we could make a bundle that's what a string is in the file and do some stuff, but you want them interleaved. It's a long story. I don't think we really want to go down that road. It's good enough as it is, so it's fine. So anyway, this will write those strings out. So assuming we have write block and write string, that will take care of the annotations for us. And really, at that point, we've, you know, we're pretty much done, I think. I mean, that's basically all there is to it. So once we've written all of this stuff out, all that really remains is to take care of the header. So the first thing we need to do is respect the fact that the header can't be written until we know all the information. So what we probably want to do is leave space for it first. So we've got the header size. We know that it's the size of whatever the header struct is. So what we can do first is just fseek our pointer for the dest file forward by the header size so that it starts out with a header size chunk missing from the beginning of the file, and we'll just rewrite that later on. So we start there, we do all of our writes after the fact, and then finally at the end we can just fseek back to the beginning of the file, like so, and then write out the header block by saying, look, you remember that header we filled out? We would like you to write it. And by the way, we can also double check here. Check header location. We can do an assertion that makes sure that the header got written to block 0 because that's where it has to go. Like if it doesn't start at 0, the game won't find it and that won't be very useful. But that's basically it. That writes the file out, I think, with all of the data. I don't think there's anything particularly fancy going on there. Otherwise, I don't know if I've forgotten anything. We'll have to double check. But then we can just go ahead here and say, all right, here's the right string. That's the string to write. There's the destination count and the destination file, like so. And then, of course, we also have the right block. That's got the size. So, yeah, I think I should make these all be 32, now that I think about it. Just because I don't think we support 64-bit sizes really anywhere currently. Everything's got to be 32-bit sizes. You can have more than 60. You can have like lots of 4 GB chunks in the file, so it could be way bigger than 4 GB, but nothing individually can be bigger than 4 GB currently. So I think we're really looking at something more like that, which is fine. So there's the data, and there's the dest file. Now these are really trivial for us to write. Obviously, the location in the file can be given to us by ftl. Which will say where it is. So if I just want to find out where we are in the file, that will tell me where we are in the file. That's where we are going to write. We can then do our fwrite. We can pass the destination file, the data, the size, write it out. And then we can use that function to implement our string write as well. So we don't have to write it twice, right? Everything can go through the same path. So when we want to write a block, well, we know the size of the string. That's just whatever the count was. We know the data from the string. It's whatever the data was. And so all we need to do is fill in dest count first with the size of the string so that that'll get written to the header properly. And then we're done, right? OK, let's see. So yeah, these have to be U32s at the moment. When we write the block out, we need to pass the dest file, which we didn't do. Let's see here. That is a typo, and this has to be that way, like so. The author name is not in there. It's just author, that's why. What? So it's, yeah, it's not name, it's just author. Okay. There we go. All right, so that's supposed to write a file. We could test it by using rewrite. But we would have a problem, which is that we'd have no idea if it rewrote it correctly. The reason for that is that we don't load HH1s currently. So really the last thing that we have to do now is make something that actually loads HHA version 1 files. This should be relatively straightforward, because all of the stuff is in the right format, so it should just be a case of literally just pointing to things. Yeah, and that's about it. So, you know, when we load the file, the data store has already been loaded. So in here, if we just look at the data store of the file as a header, we should be able to just put everything together. So for example, let's see here. Where's my HHA edit? I just need to fill out all this stuff and make it be set correctly. So actually, let me swap those two. Okay. So my head's not in the way. So if I want to figure out, for example, if this thing has annotations, I can just say header annotations equals true inside an if statement. The if statement, oops, sorry, HHA. The if statement would just be whether the annotation array had an offset, right? So if the annotations, that's in this header here, this thing. If this was non-zero, then it has them. Otherwise, it doesn't, right? We know this is set already. Magic value and source version should also be set, if I'm not mistaken. Those are set by the calling code, right? So the code, where does the load read HHA code happen? So you can see that gets set here, right? So the file and the magic value and the version number, those get read. So we don't really have to worry about those. It's the rest of the stuff that we have to actually do. So let's go ahead and fill those in. Now again, it's pretty straightforward. The tag count, the tags, the asset count, and the assets. We don't have to load anything now because it's just flat memory we can point to, and it's all correct because it's not doing an import. It's actually just it's the correct stuff. You know, it's the file is right. So we can go ahead and just cast these. Oops. We can just go ahead and cast the data store to those pieces of information, and they're right. So let's suppose I just look here and say, well, here's the header. Here's the tag count, and we know that the tags offset from the data store. I'm just going to call that D, let's say. Off of the data store, that's the value we want. Same is true for the assets, right? And then the only thing we really have to process now is those annotations, because everything else is now right, like the assets and everything are correct. So the only thing that we have to do now is actually allocate space for the annotations array and actually process that correctly. So if this thing has annotations, then what we need to do is say that we've got an HHA annotation. That's a source annotation. And that's going to be pointed to by whatever the header annotations pointer is, right? And we can do a for loop over them. Like so. Why did I do... I keep getting confused between HHA and header. There we go. So I want to make two of these now. I want to make a loaded HHA annotation that I'm going to write into. And I have a source HHA annotation, right? And so what I want to do here is I want to go ahead and load these in where I say, all right, each one of these things is going to be based off of one of these. So I can say, look, annotation index, get the one that we're reading from, and then loaded HHA annotation test annotations. That's just going to be the annotations plus annotation index. And then I just have to load them in. So we know exactly what we're loading in. It's this set of things. So we can just say dest annotation, source file date, source annotation, source file date. And the same is true of the checksum. Same is true of the sprite sheet. And so that copies those things in, and then we need to load our strings out. And again, that's going to be pretty simple. I'm going to make a little utility function for it that basically passes the base pointer and then passes the two pieces of information we need for the string. So that is the source file base name count and the source file base name offset. Okay. I don't know which is the best. I'll do it like that. So here we just load the strings in. And I think we're done. So we just need this function to do our string decode for us, and it's not really particularly interesting, right? All we're doing here is saying, well, we have a data store pointer. I guess we'll just keep calling it D. We have a count, and we have an offset. And all we're trying to do is construct the new string from that. So what we want to do is say, well, the count of the string is just the count that we're told, and the data for the string is just going to be the offset off of the data store, and that's it, right? So now we're loading everything. Ooh, HHA asset count. But we don't actually set our annotations up at all, so we need to allocate those here. That's all we need to do for that. So that mallocs an array for us to put our loaded annotations in. And it also tells us, you know, hey, we've got some annotations now. I think that's it for reading v1 files. I don't know that there's anything else particularly much in there, but now we got bugs or whatever. So we're gonna have to go in there and figure out anything we messed up. Let's go ahead and just try the basics. We can go ahead and look at what happens if we try to rewrite one of our existing files, for example. So test1.hha, let's just look at what that was originally, right? So here's our tab view. And here's our test1.hha. So you can see like what it thinks it has, like some facing directions and some assets in here. Oh, whoops. We didn't dump that one with the latest version of HHA edit, it looks like. Let's try that again. What am I missing? Shouldn't that give us a new... Shouldn't that tell us, like, what's contained in the assets? I might have to step in and see what's wrong there. So we're not producing a dump file? What did I mess up? Like, did you notice it's not producing the dump file? So something's busted. Oh. Oh, whoops. So that's not how dump works. We got to update our stuff here. So really this should be, the little switch parser probably would have been good. So we need to do a thing here that's like print usage equals false, and something like this. Because we got to make sure we know when we mess up the command line, right? Like, I don't want to be sitting there like that, scratching my head, going, wait, what happened? So we want something like this that's like, hey, you messed up. Like, that's not how you do a dump. You do a dump like this. So that's what I wanted. And now we should be able to see all of the information, right? All right. So let's launch another tab view here, and let's do some stuff. So let's assume, well, we should debug this first, because it may just crash. We don't know if it'll work at all, right? But so let's take test1.hha and do test1 v1.hha, right? And, well, it didn't crash, so that's good. So it rewrote the file, and here's the rewritten file. And it's slightly bigger than the original file, which is actually okay because, remember, we added annotation to it, right? We graphed on those strings. So it should be a little bigger, even if it's working correctly. So that's not really a cause for concern. That's actually totally fine. So let's go to the tab view here and launch it. Okay, there we go. Let's go ahead and take a look at the other dump file and see if we can see what we got, right? So we produced a test1 v1.hha. Now I'm going to go ahead and dump that one. And I did it again. Well, I should just make the dump work that way, because I obviously want it to, right? So here's another dump file. It's only 5K, but I guess the original was only 5K. Doesn't this look like more than 5K of data? I guess just because it's all spread out with the indentations, it looks bigger than it actually is. All right, so here we go. So the first thing we'll notice is these things have changed. They should have changed, so that's okay. The magic value is the same in both cases, but the version has changed. That's what we wanted. Let's take a look at the assets. So you notice we now have these descriptions from the file. These were added before. Now they're from the file, and they match, which is good. That's what I want, right? And it looks like... So we lost the asset name somehow. So we do have at least one bug. It is the asset name. Most of the rest of the things look right to me. So really the thing that I'm not seeing here is the asset name. The author's right, the description is right. The base file name's right. So really, to me, it just looks like we messed up the asset name somehow. So that's the only thing I see wrong at the moment. Is that the asset name is busted. So when we're loading it in and we do a ref string, we look at the asset name count, asset name offset, and we assign it to the asset name. That seems roughly correct, right? So I wouldn't imagine there'd be a lot of issue there. So let's take a look at the writer. Did the writer mess that up? Yeah, okay, so we did the author twice is the problem, rather than the asset name. So that's, I think, the only bug. That's pretty good if that's really the only bug. We did all that and we only had one mess up. That's pretty good. So let's just fix that. So here we're trying to say that the asset name offset is that, right? And let's run the same thing again now and see whether or not we've got it correctly sussed out. So here we'll rewrite that. Oh, we've got protection in there for not deleting something, which is kind of nice. So, okay, we've done it. Now let's dump it. And now we should be able to look and see if we've got that asset name properly restored. So it looks like we did, right? We've got head, cape, and torso. Right? Head, cape, torso. So that's pretty good to go. Yeah. So that's all pretty good. I think so. The thing that we're now left with a sort of we're left in sort of a weird position. We might as well finish up making these things completely backwards compatible. The thing that we have to do is right now we would no longer have a way to query anything by what type it was because we're effectively stripping out that type field, right? So now finally what we'd have to do is do like tag like type index or something, or like basic type, basic category or something, right? Like whatever that thing was before. And the basic category is like just whatever these things were. You know what I mean? So we could do something like, you know, I don't remember what this was called. It's called that. And so if we want to, we can basically do like a tag welding operation here, which does stick a new tag and everything, and would allow us to still retain 100% backwards compatibility, right? So let's just do it, and that'll finish up the day. And then I think at that point, we're free to just go hog wild and do whatever we want, right? We can go back into the asset system now. We can use the data storage in the HHA file to actually record information about where things came from. So we can go ahead and make that system be pretty sweet now, I think. All right. So if I want, I now have the ability to sort of specify what that property would be so that when these get imported to the type array stuff, they can be set up properly. So that just means that each of these things is going to have an additional tag grafted onto them, which means that this stuff here has to continue to work properly, and this stuff here has to be offset. So like our tag importing has to be beefed up a bit, right? Not sure exactly how I want to do this. I do want to do one thing though. I would like to truncate this before the extension. So if you pass a string, I would like to do something where we check and we get rid of any of the stuff that comes after the last period. So pretty straightforward. If we see a period, we just set the new count. And that's it. So basically we look for the last period. We could also do a thing here where we check for slashes. So if we want to support file names with the path in them, basically, what you could also do is say something like so basically you can't truncate if there's a period in the file. If a slash comes after a period, then forget those earlier periods. You know what I mean? So I just wanted that in there because I would like to get rid of, what did I do? That was a mistake. And I admit that. Probably should do this. So that way when I do those conversions, like when I do the rewrite here, and do the dump, then I should see in the name, it's just node.hha, right? It's just the base name, because that's what we've been going on at the moment, right? All right, so that's pretty simple. Yeah, we could also truncate. We could also truncate path names here. So, we can have both of these. I wonder what I should call this. Maybe like truncate. Maybe I'll just call this remove extension and remove path. So if we find one of these things, then what we want to do is say, well, okay, the new count value, I'm going to say 0. Could call this new start. So if we encounter one of these, then we know that the start is going to be the index plus 1. So then what we're going to have to do is say, all right, the file name count minus equals the new start position, and the file name data plus equals the new start position. So it's basically advancing to the path part. And so that way we can say, like, all right, yeah, remove the path and remove the extension of this thing. And then what I should be able to do is say, well, okay, so even if I was to do something like this, where I said, oh yeah, like go back a directory and then forwards a directory, hopefully I would still get a path parse there. Oh, well, I've got to actually do it this way. Like that. right? And so then if I dump that, hopefully we'll still get test 1, even though that's not what would have come in on the command line. Yeah, so that just cleans it up and produces just the name, which is what we kind of said we were going with. Why? Well, you know, it's what we said we were going to do, so we did it. So I think all of that is now good, and I just want to add the that tag back in so that we could still use the old files. And so before we decide on a completely new set of tags and what we want to put in there, we can still load the old tags just to verify that everything's working. It's just nice because it doesn't cost me that much to add it here. It's not a lot of work, so I might as well do it, right? So we know we're going to add one new one each time here, so we know we're going to have a lot more tags than we used to. So we're adding the asset count in. Then what we need to do as we loop over these here is now we actually have to copy the tags out. So this is not going to cut it anymore at all. So we got to like change that. And we got to do the copy for each of our assets here, where we loop through and process the asset. That is where we have to process the tag. So what we need to do is say for each tag that we would have copied, so this is like asset tag index, basically. What we want to do here, well, I guess we can still do it as tag index. So what we need to do here is say, well, we've got the asset, it's source asset. We know that the first tag index is this. We know that the one past last tag index tells us what to loop to, right? So we loop over all those tags. We know the source tag is here. So the only question is, where's the dest tag? Well, the dest tag is just going to be something probably that we do this with, right? And then finally, after we've added all of those tags, you know, and I guess I should probably just do this. Right. After we've added all of those tags, we have to add one additional tag, which is ID and value. So what we want to do here is add this stuff in. So basically, you know, we know what the original type ID was, the thing. We're going to say that's the value of this. And we're going to say like tag basic category is the tag ID. So we added that category in. That gives us the tag set for this asset correctly. And so then what we need to do is set this up. So pretty easy, right? We know the first tag index is just whatever the tag index was that we started with, and then we know the last tag index is just whatever the tag was that we finished with. So pretty straightforward to set up, right? So the only thing we really have to do is just remember where the dest tags are, right? So it's just HHA tags. I probably just should have done HHA tags, right? So all I really have to do here is just say, all right, the dest tag index starts at 1 and goes up from there. And this should reserve the space for that because the tag count in the file includes the 0. So it should just work going forward, I think. So that all seems fine. Yeah, I don't know if I'm missing something there, but I think that's everything that we would have had to do. So let me delete that file. Let's rewrite it. And then dump it and see if it actually did that at all. So if we look at the tags here, you can see what we've got. It looks actually correct. That looks a little odd. There's another one, but maybe it's right. We'll find out. I'm not sure. We'll have to look into that. We now need to update the array. Again, this is one of those things where I say C++ is awful because we shouldn't have to do this. This should have been automated, right? And it's trivial. Like every programming language except C++ automates that trivially. So anyway, we get these unknowns here. If I rerun it now that we've added that entry, those should say basic category, and they do. We've got an extra one here, so that feels like just a screw up. So I should go look and see. We must be allocating one too many tags. And we are. The reason that we are is because of the phantom 0 asset, the gift that keeps on giving. So we only need the asset count -1, right? Because we don't need an extra tag for the 0 asset. It doesn't get any tags at all. All right. So now if we go ahead, delete, rewrite, and dump, we've got all of that information in there, and all the tags look good. Everything looks good. So this allows us now, if we want to be able to load version 1 in the game. So let's go ahead and try that. So here's how we would do this. You can see we've got all of these HHAs in here. So what I'm going to do is I'm going to delete all of this stuff out of here till we have just the HHAs involved. So you know what? Here, I'll just make a v0 directory. And I don't want that. So I'm just going to move that out there as well. Test that out. I don't remember what this thing was. Oops. Guess you can't drag and drop. Why is 4coder not a drop target? It should have drop files set or something, right? All right, so I'm going to delete these dumps, get them out of there. Delete this test, and delete the import test as well. Now we've got this test.out file. I just want to know what it is. It was something we had done for testing purposes. So I don't know what that's for. And I don't care. So that's going to go away. So now we've got these, and I want to import them all to the new file format. So what I'm going to do is I'm just going to use HHEdit to rewrite them all. So again, hopefully we're doing this correctly. Don't really know. Well, the only real way to know is, beyond what we've already tried to validate, is to actually go and try them in the game. So that's why I want to do it. And there we go. So now we have v1 versions of each of those, and I can just store these in v0. There's our v1 versions of everything. And I should be able to dump all of those. So if I want to look at one of these, intro art v1. Oops. Here's the dump of that file, and if I bring up my tab views, I should be able to walk through it pretty easy. All the tags look good. Here's the assets. They're all opening cutscenes. Everything seems kosher. Okay. So that seems good to me. If we pop back over to the game now, of course, what's the unsaved change? I don't know what the unsaved change was. Oh, it was the test.out, probably. I don't know. Anyway, if I pop back over to the game now, though, the game wouldn't work, right? Because it doesn't know how to load those files anymore. So the game will break because it's expecting to load things with a very specific structure, and it can't load them anymore, right? So now our goal is just to bring the game up to the new file format, and we can just proceed from there. So doing that is, the first step is to make, eliminate, there was a part of the code, remember, where we tried to put in the shim. So this was just saying like, hey, we don't want to port to the new file format yet, so here's the thing that forces it to load the old file format. We want to get rid of this. So we want to go ahead and compile that. And now we should get compile errors everywhere that we don't, we will get compile errors everywhere that we need to update the file format to do like something new with it, right? So the asset type here, oops, is not really an asset type, right? It's actually just a thing. Let's see if you can see it there. Yeah. It's just a thing that we pass in. It's really not. Where's my? Where are these defined here? Layered scene. There it is. So you can see here that all of these are just set to asset opening cutscene, except for this one that's set to asset none. So really all that is it's just the thing that tells us which one of those things we're looking for the old compatibility stuff. So we can, if we want to, in handmade.h, just include the old, like handmade file formats v0.h, right? And as long as we make sure that v0 always has that ID appended to it, then we can make sure that the only people who ever use it are people who actually really want to, right? And because it'll still work just fine. Okay, so for entity visible piece here, again, like these are just old compatibility ways of doing this, but they're fine, right? They will just get looked up slightly differently at the moment. And then, like I said, the big thing we're going to have to do is figure out how we want to actually look these things up, because that's probably going to change a little bit now. So I do think we're going to want to pull this eventually, you know, at some point. All right. So the first thing to recognize is the file header asset type count. The asset type count is not relevant anymore. We got rid of that. So we just have assets, and we don't have to think about it. We don't have to think about that part anymore, right? So that's kind of nice. It simplifies our loading too. So that's going to be nice. Let's see here. What do we got? This is just when we're writing the modifications out. So for writing the modifications out, we would still have to write out the, so although this isn't necessary, we have an additional one here. We've got like this stuff, the annotations want to be kept, want to be preserved here as well, right? Trying to think, like, I kind of feel like we almost want to have that code shared. That, like, the code for loading and rewriting the annotations feels like we just kind of want to share that code. I mean, there's two ways we can go with it, right? One is we could weld the annotations directly to the assets, and they're always just written with the assets. and the other is we just rewrite the array. Thinking about it, rewriting the array does seem reasonable because you can just, yeah. There's really no reason not to just rewrite the array, I guess, because the array references strings that are still there. So you don't really have to worry too much about that aspect of it. So I think it's fine the way it is. I think it's fine the way it is. So I'm gonna nerf this temporarily, and then I'm gonna come back and add the annotations to it, because I think we can just preserve those trivially, and we should, because why not? And that's when we're gonna be able to weld in the part about the checksums and testing for the date as well, which we do want to do. All right, so asset type array is going away. This right here, not a thing. Right, so that's just gone. And this we kind of still do want to do, right? Like we want to do the annotation or asset count annotations. So we do, we do still want to be able to retract the watermark in that way. The asset type count here, we don't need to loop over this this way anymore. We can just loop over the asset indices directly, and that is what we want to do, right? So what we want to do here is like nerf this part. We want to grab this. Yeah, so this is just reading the data from the file and then unpacking it, right? That's all we're doing. So we really want to do this. We don't have any way to really handle this specially, so we kind of want to do that, right? And put that in here. So if the type is if it's a font glyph type, then we need to be able to set the bitmap ID offset. Why was that stored in the file? What is that doing? What is that doing? But why? So why would that have anything to do with whether or not it was a font? Like, why isn't that just always... I mean, that value... That does not make any sense at all. So the bitmap IDs in the font are going to be relative to the file, right? So what... I do not understand why was that just not always set? Like, why did it have to check to see if it was a font glyph? You know what I'm saying? Like, when you come through on a file and you load the file, why isn't that just the setting? Because you want to know what the asset count was, and you want to subtract away whatever the... Yeah, I don't. And so, like, why aren't the font bitmaps just like? Why isn't it just this? Like, why were we doing it any other way than that? I mean, shouldn't that be the way that it's done? And I mean, if you didn't do it this way, then it would just be wrong. Like the file, you couldn't have more than one font per file, right? This just seems really messed up to me. And I don't know why we would have done that. That's super spooky. Like, if we... Oh, no, that's what I wanted. So if we dump that file out... oops, no, bad, wrong, stop. That's going to go forever as Windows is super slow at building those tab views. So if you handed a lot of data, Windows just dies trying to populate the tree view. You know what I'm saying? It can't do it. All right, here we go. So I'm just curious. So if these are the assets here, right? Like there's two fonts in this file, aren't there? Maybe there aren't. I mean, I thought there were. I thought these were two fonts, right? These numbers don't make any sense, I can tell you that. We should maybe dump the glyph information here so we can actually see what it is. Because I do not fundamentally don't understand what's going on there. I'm just confused. It doesn't make sense to me why it would be the way that it is. It should just be a file relative index for the glyph. Full stop. And so all you should have to know, you shouldn't even need to know font bitmap ID offset. Like, you should just have a thing that's like asset base. Right? Like there's tag base, there should just be asset base. And then all you do is you add the glyph index to the font, to the asset base. I mean, that's all that it should have done. And I do not understand why it didn't do that. Maybe there was like a historical reason why or something. So I don't know, man. I think that should be asset base. I don't think it should be font bitmap ID offset because the bitmaps should all just be relative to the file, and so whatever file the font is in, it should just use the asset base of that file. That's what I claim, and that's what I'm doing, and I will just make it work because that's the only thing that makes any sense to me. So how does the tag base get set up here? So yeah, a lot of this stuff just doesn't make sense to me. So the tag base is set up Oh wait, no, that makes perfect sense. Never mind. I thought that was getting it out of the header. So yeah, no, that's good. So as we do our asset count here, right, the base for loading these is whatever the asset count or the tag count is, right? So that's exactly what we want. And then we go ahead and add in the new ones here. We don't bother with the 0 value, obviously. So now we know for every file it has an asset base and a tag base, which is what we want, right? And I feel like that's what it should have been. So I didn't really like the fact that it wasn't that. It was lame, right? So anyway, moving along. So we've got this very bad spelling. This is how you spell exercise, just in case anyone was wondering. Do you know why I spelled it that way? So anyway, exercise for the reader can still remain, but everything else, all right. So I don't know. I'm just gonna go ahead and claim that was because maybe because of the way we came at it, we originally were only loading one kind of file, and then we added multiple files, and I don't know. Like, I'm just gonna claim that was just like vestigial remain kind of stuff, because I mean, obviously, when you output a file and you put bitmaps in it, all of the bitmap IDs in that file would just be relative to the file. So if you know where the file got loaded in the asset indices, it's just a given. Like, it shouldn't be any more complicated than that. So I feel like that was just a mistake. And so I'm just not gonna, I'm just gonna say that that's not the way that goes, right? So when we load in our HHAs here, I think we could do the same thing we were doing before with the tags. So I'm just gonna say, look, if there were assets in here, then we're gonna load them in. I guess we don't use, do we ever, because we need these to be kind of expanded, I guess, so there's no point in us loading it off of the base value. So I guess now I think about it, we don't really care too much about that specifically. So I suppose that's okay. This right here is now known. It's the file asset base, so we don't need that. This we also don't need because we know that it's all the assets in the file. So we're going to load, all of them. So it's really just like file asset count, and that's just the file header asset count -1. So we can just do if file header asset count, off we go. And this is already looking much better, so that's nice. We can start the temporary memory here and do our load into the temporary memory, which is what we do. We've got the file asset count. We make a temporary array for it. We read that out. This is just 1, right? We skip the null. We load that many in. We then loop over them like so, and we go through each asset that we loaded, grafting it on to the assets that we already have, right? Yeah, that's really all there is to that, I think. So all of this stuff should be right. Everything else seems right. So that should load all the assets in. And off you go. So we now know that the asset type ID in this kind of asset type ID that we're talking about here is actually not this piece of information actually isn't like the font or whatever. This is actually now a tag, right? It's a tag that's in the actual tag array. So in order to figure out what's going on there, we need to look it up in the tag itself, right? So we actually have a thing here that's like, you know, asset type ID v0 type ID equals asset type. What was it? Asset none. So we're going to load this one in here and say, okay, we now know what the type ID for this thing is if we don't find a tag, which is it's nothing. If we do find a tag in the tag array, and I guess we're going to search the tag array here, that has that, then that's the tag that we use for it. So we can loop over the tag array here. HHA asset, first tag index. I guess I actually want to just do it this way, because that's where the tags are. So now when I loop through these, I can just look and say, well, whatever the tag is for this, if the ID of that tag is the basic category, then the type ID equals that tag's value. And that's it. So asset index and file is always going to be that. Oops. And off we go. All right, so we've now recompiled the game for loading v1 asset files. And what we want to do now is just take a look to see whether any of it works at all, right? We're already compiled in debug mode, I believe, so we should be able to step through this code pretty easily. So let's just see what happens when we do. We end up with an asset set that's got, you know, whatever in it. It's got a bunch of files. Let's take a look at what they are. It says 6. So I'm going to go ahead and see what the 6 files are. If I go and actually view how many files there are, in here I see there's 1, 2, 3, 4, 5 files, which is, you know, not 6. So I believe that's because we just leave file 0 as a non-file, right? That's the, like, I don't have a file, like an empty slot. So we start with file 1. We say, okay, that starts at 1, 1. There's the watermark, which is where the data can be appended. We've got the header. Here's the tags and the assets in there. It says that this thing, whatever this file was, and I don't remember what it was, actually. It had 203, 201, so I'm assuming that must have been the fonts. Isn't that the only thing? Or, oh, well, it could have been the intro art, I suppose. Yeah, it was probably intro art. There's probably that many bitmaps in there. So, you know, it seems all right. Everything looks okay there, I guess. Seems all right again, yeah. All right, so it seems reasonable. Coming through here, we load in the tag array. Let's make sure the file could read that okay. Where's the no errors? There it is, no errors one. Look at the asset count. There's 200 of them. Seems reasonable. We're going to go ahead and load that. Do we have an end temporary memory? Yeah, we do. Everything seems pretty good here. Seems pretty good. All right, I mean, it seems all right. Let's see if we get any errors here. So we are able to load the whole thing, which is good. So looks successful. The tags are operating properly. The search is operating properly. So that imported everything correctly as far as I can tell, right? So off we go. Right, so that's good. So I think that really does leave us, I can do some more work today. I can put 15 minutes into cleaning up the rewrite part. Let's make sure also that we are running at a reasonable speed and that there isn't something weird going on with the debug build as well. I mean with the release build. But I assume that was just the debug build there. Yeah. So everything looks good there. The one thing that I do think we need to debug, you can see that the fonts are messed up, right? So that offset, we got to go find out what's the deal with that offset. Something weird is going on with that offset, right? And I do not know, because I was just totally confused as to why it's even doing what it's doing. I need some to go refresh my memory as to what was even going on there with the fonts. So if you look, for example, at what's happening here, you can see that we're only off by 1, I think. Because if you look at what these values are showing us, you can see the letters NT. And if you think about what was supposed to go there, it was milliseconds, MS. So if MS was what was supposed to go there and NT is what is there, it means that we are seeing a font glyph that is 1 away from what we actually wanted. So that offset is pretty straightforward. It's just off by 1, it seems, right? So this, when we're coming through here to load these out and we use that asset base, the asset base tells us where the offset would be, but I guess if we think about it, it doesn't include the fact that there was a 0, right? So you need there to be, the asset base says I loaded here, but I didn't load my array. I actually loaded 1 off from there, right? So technically, like, the asset base is not really the asset count. It's really the asset count minus 1. Because everything you would have loaded is slid over by the fact that we removed the 0. So I think that was probably the only problem. And yes, I am correct. So I think we're all good. our frame display is looking bad. Our OpenGL render commands is sucking. Is this like inaccurate or something? Because it doesn't seem right when I look here. Like, I guess because these are getting summed up is why, but you can see that like most of our time is spent waiting around for OpenGL at the moment. Yeah. Anyway. So, yeah, moving on. We are completely upgraded to our new file format now, and that means we can, at this point, change this file format around however we want to, and, you know, decide on what we're going to have for our V1 file format, and just do the conversion and be done with it. Now, so what I want to do now is just finish up what we were trying to do with the asset importing. When we import now, we have the ability to store those annotations. That means that I think, and I could be wrong about this, but I think if I want to, I can actually drive the asset source file stuff here. This can actually just be driven off of the this can be driven off of what comes out of the HHA, right? And so what that means is that all of the stuff, like the asset index stuff, all of this stuff can, when we load an assets out of the file, if it has the annotation array, we can populate our asset source file information directly out of the HHA, which means we wouldn't have to store any longer, we won't need to store any sideband information, which is pretty awesome, because it means, like, if you get an HHA from somebody, if you just pass around an HHA, then you're done. You don't need, you don't need to pass around, like, a text file that also says, like, where the stuff comes from or anything. It's all kind of embedded in there, which seems good. So, I don't know how much time I got left here. I guess I got 10 minutes left. So I'm not really sure what I want to do. I might just want to go to Q&A because I think the next thing we're going to want to do is probably going to be more involved than something we're going to do in 10 minutes. Because basically the next thing we want to do is we want to make the writing and the annotation stuff work, but we kind of want to then go, we're going to want to do that, which could take a while. And then we're going to want to start figuring out how to do the tag. Like, we need to start creating some stuff and figure out how we want these tags to work. Because, like, we need to start going, like, okay, let's try to put all the art assets into the game, and what is the way that we want to specify that information, right? And we're going to have to spend some time iterating over that and, like, figuring out, like, okay, what is the most robust way of saying stuff like, okay, that, you know, I'm trying to create a floor tile in the room generator. How do I articulate to the game asset system what I want this floor tile to look like, right? And there's a huge continuum to, like, a very vague set of things, like, it's sort of indoors, and it's supposed to be wooden, and it's, you know, right? And it fuzzily matches on that, all the way to, like, I want it to be bitmap 37, right? and finding that middle ground is now because we need it. We have art assets. We got to finally say here's how they get looked up. So we got to consolidate the tag system and figure out exactly how that works. So I think I'm going to save that for next weekend, and we can go from there. So I'll go to the Q&A now because I just don't feel like starting on something I can't finish, or at least get some reasonable amount of the way through. I will answer a question I see from the pre-stream there. It said, have you tried LDB? I use that at work and it seems to be stable. I've not. I probably should, because GDB is just awful. It crashes a lot, like 1 out of every 3 runs for me or so. On a totally vanilla system. Doesn't even have a GPU. It's an Intel integrated graphics, so it's not even using any proprietary drivers. It's just vanilla Ubuntu. And like GDB like just doesn't even work. It crashes all the time. And it's not, and I should mention, it's a command line app. Like I was debugging a command line app. Doesn't open a window. Doesn't talk to X Windows at all. Right? It was just like a C runtime library, simple application. It opens some sockets and it calls malloc. Like that's it. GDB crashed all the time. To be fair, I guess it links with curl, and curl is probably a big sprawl, so maybe there. But I mean, curl doesn't open a window, right? So how come the shaded debug window with the grass makes transparent pixels around the main character white? Because we use depth peeling and we only have a few depth peels. So when you start to put debug overlays on top, it takes up the depth peel that you would have used there. That's what's happening. Why is there is no file there if it's in the way all the time? It's so that you can use file index 0 to say that you didn't come from a file or that you're not talking about a file. If you need to run a bunch of regex substitutions on huge chunks of your code base, how do you go about it? I don't. I never do that. I agree it would be nice to be able to do that sometimes. But you know, I've never really... The problem is just that you really don't want to do code-base-wide substitutions automatically with something that doesn't understand code, and we don't have that right now. Like, you know, if I say I want to change the global variable that's named this to this, that's a really easy change that should just work. But because text editors only know text and this is code, it doesn't work, right? So I tend to just, since I don't often have to do what you're talking about, I just do them manually when they come up so that I can inspect every file and I go through the changes to make sure that nothing screwy happened. And I wish that were not the case, but like that is currently the way I do it. And you know, there's been refactoring tools and stuff that people have created, and like, you know, IDE plugins for this sort of thing. My experience with those is they're always more trouble than they're worth. Again, because I do this sort of thing so infrequently, those tools tend to be kind of crappy, and then now this is another thing I gotta maintain, and the versions get off and it doesn't work, or it doesn't support something I'm doing, or it gets confused by a macro, or you know, it's just... People have tried to make things to do those sorts of things. They often just aren't good enough, is I guess what I would say. They don't save more time than they waste because I just don't have to do that very often. So... And by the way, you don't need to put Q colon in front of things. You can put at Handmade Hero. That actually does work. It's just the Q colon's a lot more convenient. So the thing grabs Q colon and at Handmade Hero. It will grab. I think it also grabs at Senioritori. So it basically, like, if you try to address a question to me using the traditional Twitch way, it will work. It's just a lot more typing for you for no reason compared to Q colon if you're on a tool that doesn't use autocomplete, right? Oh, yes, thank you. Somebody took my name for mentioning that the glyph... Didn't it seem... Am I the only person who felt like the glyph stuff printed out wrong? Or if it didn't print out wrong, then something's weird about it anyway? Where did we print that out? Here it is. Okay, so yeah, it was just backwards. So that's at least reassuring. That was just a simple typo. VTLMKS, not really a question, but why EFI? What problem did they make up to have EFI solve? Are you referring to the BIOS standard? I just want to make sure I don't answer a question that's not the one you had. Like, are you referring to... Are you referring to this stuff? Yeah. So... where to start? As with most things, I don't think EFI was making up a problem to solve. I think it was solving a problem, right? Pretty much everything standards-wise that we make is in response to a real problem. However, like many things, rather than solve the problem that it was in response to, what they actually do is just create a lot of problems. You know? And so... most of the time, standards are just a mixed bag in that way. If you take a look at the BIOS that was originally before EFI, it was pretty good, right? It was really easy to say, here's how you do a disk I/O, here's how you switch the mode of the graphics card, right? It's easy to read. It's easy to program for. It was really kind of enjoyable, right? And easy. But, hey, do you want to know if there's a USB device connected? Do you want to boot off the USB device, right? That's something that we do all the time now, is boot off of a USB drive, for example, right? Well, that's not in the original BIOS stuff. There wasn't USB when the BIOS, original IBM BIOS stuff was specified, right? And so... at some point, because remember, the IBM PC specification was originally created by IBM. That's why it was called IBM PC. And it was created at a time when there were very, very few things for the computer to do. And so those were the things that were in there. You know, there was a fixed keyboard kind of interface, a fixed mouse, if any. You know, I don't even think the mouse may have not even been there in the original ones, you know. And so there were just a lot of things that were really pretty underspecified in that original spec. And so at some point, somebody has to say, here's how we're going to handle all these new things. And so EFI was necessary and UEFI were necessary to address those missing features as PC hardware started having more and more things that needed to happen at BIOS time. Because, you can have drivers and stuff and do things that way once the operating system is actually booted, but where does the operating system come from, right? The BIOS has to be able to bootstrap things together, and if you fundamentally don't have a BIOS that understands a bunch of things that happen in a modern PC, then that doesn't work. So I totally understand why you might think EFI is bad. It isn't good, but that doesn't mean that the thing that was before it was sufficient. It wasn't. So really what we would say is we wish they had made UEFI better than it was, but I don't think you want to go back to the time before it, because then you'd be giving up most of the things you can do with your computer today. You would have to use a floppy drive to boot and stuff, right? Well, not really. You could boot off a hard drive, but how would you have installed the stuff on the hard drive? You would have had to boot off a floppy, and that floppy would have to have contained drivers for your USB stack, which you then could plug a drive into. And I'm not exaggerating. That's really what would have to have happened. The other thing you could have done was they could have had a legacy mode that if that had a USB port, that if you plugged a drive into it, it had a driver for the USB specifically on a BIOS on that port that then made it look like an old AT hard drive that worked with the BIOS, So, you could get around these things, but you see how janky it is, right? So it's not unreasonable that they wanted to come up with something new. It's just, would it be nice if it had been better? Sure. Not the same thing as saying that it was superfluous. Dark Sprites, bit of an off-topic question. I found your talk about GJK and implemented it for my project, but now I don't know what to do to resolve collisions when I detect them. What should I do? Well, I don't know. What do you want to do in your game when things collide? I'm not sure how to answer that question. There are ways of extending GJK to find the time of intersection, which may help you. You can add the motion vector into the GJK solve and then back out of the GJK solve and figure out which face you left through. There's some stuff you can do there, but can you give advice for someone who wants to drop out of college and just finally get a programming job, or is it a big no-no nowadays to do so? I can only tell you secondhand information because I don't work with large hiring organizations or anything like that. Here's what I'll tell you. From what I have seen, almost no interviewers or hiring managers at software companies care if you have a CS degree. So it is true that you probably don't need to finish your CS degree to pass that part if you are good. But here is the rub. In order to get to that stage, right, you would have had to go through some kind of screening process through human resources or however that company screens their applicants. If that company screens their applicants based on whether they have CS degrees, you'll never get the interview, right? So I think you have to first sit back and ask yourself, where am I going to try and get a job? And what do I think the chances are that I can ever get a foot in the door there without a CS degree, right? Because remember, there's a lot of things that a CS degree gets you that have nothing to do with programming. Connections with, that your professor might have that could get you a job, access to job fairs where people recruit at your college campus. Just the fact that you have a CS degree means you might be able to apply for immigration lotteries, right? Like in the US, if you have a degree and you're from outside the US, you are more likely, I think, to get a immigration visas for working here. I don't know if that's still true, but I believe it was true at the time. There's all kinds of reasons why a CS degree may be important to your future that have nothing to do with whether you learned anything while you were there, right? So you can't just think of the degree, sadly. We think of college as a place you go to learn stuff. It's not only that. It's the first part of a filtering process that other companies use to determine who they're going to hire, and you have to be aware of that. Just because that seems unfair or unnecessary doesn't matter, because all that matters is that it's true, right? Right? So you have to be realistic when you're weighing your options about that. It may be true that a CS degree is a waste of time. It may be that you aren't going to learn anything useful there. I'm not saying that's true. I'm just saying maybe that is true. But if that is true, that is not dispositive. That doesn't tell you, therefore, there's no reason to stick it out and finish. That's not true. There are a number of reasons why that CS degree, as simply a piece of paper, may be important to you. So be sure you understand those trade-offs before you drop out of college or believe that your CS degree is not going to be valuable to you, because it's not just what you learn. It's also what other people have put in place as barriers that CS degrees allow you to bypass. So just keep that in mind. The second part of the question is, how do I get a programming job with that or without the CS degree? I think to a large extent it depends on what kind of jobs you're applying for. Demonstrating that you have skills is a good way to go. Why should I hire you? There's tons of people out there who program computers. Most of them are lousy, and I wouldn't want to hire them. So my question is, why should I hire you, right? What makes me think that you are going to be the kind of person worth spending time on to bring onto my team, teach how to do what we're doing, and that you will start contributing? If I can go to a web page, like if you've got a blog or something, and I can see you have posted write-ups about stuff that seems like you've done investigation into things, that you've explored things, that you know how to program, that you've made some interesting programs, that you understand how they work, right? That can be a big plus. I think programming is more like art in that way in some cases that other people think. If I can see a portfolio of a programmer, I am much more likely to want to talk to that programmer and ask them questions and see if they're good than if I just, you just say, I worked here or I went to school here. I want to see some stuff, And, at the pro level, you can see the dream version of this. Go look at Fabian Giesen's blog, right? Let's say you didn't know who he was, and his resume comes across your desk, it's not going to, because there's a line a mile long of people who would want to hire him if he ever left his current job, so not relevant. But you go look at his blog, and it's just entry after entry of really detailed technical analysis of things. You just know that person is going to be someone you're going to want to interview, Now, there could still be reasons why maybe a person with a blog like that isn't someone you want to hire. Maybe it turns out they don't do work very much. They just do blog entries and stuff. So they explore all these topics, but they don't ever get anything done. Right? That could be true. But you at least know that person is worth your time to interview. So when you see someone who's like, here's all this stuff I've got, check it out. Like, I care a lot about tech. I do a lot of work programming. I'm really interested in learning new things and figuring stuff out. Please talk to me. If I can see that you've done stuff, I'm like, right? Like, good. Now I feel comfortable saying, let's spend an hour talking to this person, because I don't any longer have to guess about whether they might be the kind of person who could, who has the intellectual curiosity necessary to be a contributing member of a tech team. So that's what I would say. First, understand whether you need a CS degree or not. I'm not in a position to be able to tell you that, because I think it's highly context dependent. You may need one, you may not. And then second, figure out why you are different from every other person who's applying for a programming job. If you can't answer that question fairly definitively, then you had better stay with your CS degree, right? Because if you are not at the point yet where you can demonstrate why you are an important person to interview, then you need all the help you can get, right? You are not in a position to drop out and try to get a programming job if you're just going to look like everybody else. So figure that out. Figure out how you're going to get my attention. And when I say that, I mean HR's or hiring manager's attention, not me, because I'm not going to hire you, obviously, but whoever it is that you're trying to get a job from. Long Boolean, I am a bit confused by your answer because I have booted from USB on pre-UEFI systems, so I'm missing something. I believe those were exactly the kind as I described. So pre-UEFI, I believe the way that it worked was the thing that I literally said. They had a certain USB port that if you plugged the USB drive into that port, it would make if it had, a standard FAT32 file system on it or something, it would allow you to make it look like a drive to legacy BIOS. And I'm pretty sure that's the only reason that stuff worked. It would basically make it they basically implemented a USB drive protocol for a limited set of USB drive scenarios onto a port, so they just looked for that when you plugged it in and went. So basically what they had done is a non-standard UEFI style boot, right? Because there's nothing to stop a system manufacturer from making their own BIOS that does all this crazy stuff, but that no one can access. So it just makes everything kind of look like it used to. Oh, you plug in a USB mouse. Well, we wired that up to look like a PS2 mouse, right? They can do all that stuff, and BIOSes did, but it's all non-standard, and you can't write anything like a Linux bootloader that uses it, or Windows can't take advantage of that to help you install the system, and blah, 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 right? So it's just about standardizing that so people can work with it instead of just making it entirely custom to one BIOS, and it can only do the things that they decided to implement in the way they decided to implement them, period, right? Can you give an overview of how you've structured your web programming in C? I've heard you mention it in some stream on how you made certain components behind the Handmade Hero website in C, or at least more sanely programmed than most web frameworks. It really interests me. Could you give me some more info? Well, I mean, sort of. Basically, we have a C system that generates all of the website that's static. So everything that doesn't, and static's a loose term here. Obviously, it's all updatable, but static meaning it doesn't change like minute to minute. It changes like day to day, right? So, for example, the Handmade Hero schedule might change frequently, or whether or not I'm online streaming might change frequently. Whereas the content of our website might only change once a week, like when we post a blog or something. So there's a C system that just generates all of the everything for the website that doesn't change more frequently than once a day or every day or two, right? Or a week, a month. Greater than day granularity. And all that stuff just gets uploaded to a CDN. Just as a giant bulk. It's just like blah, right? Here's the whole site. Everything is generated. So that basically takes, all of the pieces and welds them together into static pages so they can be served quickly, Because obviously, the button bar at the top of 30 pages is the same, but you don't want to be pulling that in dynamically because that just wastes time and it's a slower page experience. So that happens. All that stuff gets pushed to the CDN. Then there's a separate server for handling dynamic stuff, running a C program that basically answers queries as just a simple Apache CGI bin. I would like it to not be that, but I just haven't gone the extra mile yet and made my own web server. I probably will someday, because Apache is a piece of crap, and I hate it, and the configuration is ridiculous the way it works. And CGI bin is garbage, so I don't like that either. I don't like anything about it. I could split the difference and make an Apache module, but I really don't kind of want to go down that route. So at some point, I'll probably make something that just sits on the SSL port and watches for packets and responds to them appropriately. But at the moment, I'm not doing that. At the moment, I just run Apache with a CGI bin. What that does is it just provides any dynamic stuff. It's a C program. It knows when it gets a request. Those requests are usually sent as URL encodes. Pretty much exclusively. So the only communication into that is a URL, basically, right? It hits it with a URL, it decodes the URL and figures out the parameters are based on that. It then sends a JSON file back. The reason it sends a JSON file is that seemed like the most compatible thing. Like the web browser just has a JSON parser in it. So you don't have to add any additional JavaScript code to parse something. You can just run the JSON parser. So again, it's all about keeping the page size small for me. So that seemed like the simplest way. So it sends a tiny little JSON packet back with the information that was requested, and that's it. That's the entire web architecture. And by the way, we have the fastest page I've ever used. Like, I go to our website on a mobile phone, and I'm like clicking the thing, and it's so fast and responsive, and I then switch to like Twitter, and it's nuts. It takes like 7 years, and I'm like, what is going on, right? So I don't know what web devs are ostensibly doing, other than sucking. Like, it's just like, the web should be instant. I can prove that because ours is. And I do not know why. Nothing should be slower than our website, right? I have no idea why everything's so slow. You go and you look, and it's nuts. Even the things that we don't make on our website are super slow. YouTube, we have some embedded YouTube videos, super slow. Sendowl's purchase button, super slow. It takes longer to push the Sendowl purchase button than it does to load our entire page. Like 8 times longer, right? I don't know. It's embarrassing. How about learning some online courses at Python or something? I have no idea what that means. You talked about people needing to know C++ to be hard for programming jobs these days. Did you mean OOP C++ with compile times linked to lunch breaks? Do you think you would need to bone up on newer C++ to do such a... Yeah, kind of. I mean, I think that any project that takes longer than a few seconds to compile is messed up, right? Like a 10-second compile is already a bit too long. And so if if you can't compile your project in 10 seconds, you had a big problem. So I think these OOP C++ code bases are ridiculous, right? I think they're just wrong. I think they're just wrong-headed the way they're designed. But what me thinking they're wrong-headed and that there are jobs to work on them are two totally different things. There are tons and tons and tons of code bases like that out there that are huge, sprawling OOP messes, tons of templates all over the place. They take forever to compile. It's nuts. There are many, many, many jobs working on them. So if you are looking for a job and you're not like some amazing superstar programmer that everyone wants to hire so you can just, pick the 3 places that don't have weird code bases like that and be, picky, then you need to know that stuff, right? Because if you don't know that stuff, then, you're not really qualified to work there. Now, you may still pass the interview, right? So it may be that you can learn that stuff on the job, right? I don't know. But it's entirely possible that they include sort of some at least basic OOP C++ template nonsense in their interviews or in their programming problems if they give you those. And so I don't think you really want to go into a job interview not knowing that stuff, right? I mean, maybe this wasn't clear, but I actually know a ton about the original C++ programming. I mean, I've written templatized math libraries. I've done templatized callback functor stuff. Like, I did all that back in the day. I just thought it was bad, so I stopped, right? So saying that that's not the way I think you should be programming because I feel like it leads to bad results is different from saying you can just not learn it. Because unless you always program it by yourself or you happen to be lucky enough to be hired by a team who's sensible, which there aren't that many of, it's gonna be relevant, It's gonna be relevant, and you have to be aware of that. That's why it's a job. That's why you get paid to do it, right? If it was always your way all the time, that's not a job anymore, right? That's just recreational. So, one of the ways that you earn your money is by programming some stuff you don't want to do, right? And you just have to think of that as that way. How can you create an interesting portfolio for back-end developers? I can't make fancy sites because I know nothing about design. Well, let's take a look. Suppose I'm a back-end developer, because hey, I did the back-end for mollyrocket.com, right? Here's one of our sites. So suppose you don't know how to make any of this stuff and you're like, I don't know, I want to show my back-end development skills, whatever. Well, here's the people we tried to use for our mailing list originally. Don't ever use them for mailing lists. They literally are completely incompetent in all possible ways. I don't even want to go into how many things are broken about their service. It's nuts. It's really, really, really bad. And you won't know that it's broken until you start actually auditing it and figure out that half of the people who try to sign up for your mailing list don't actually get signed up. It's really bad. They are really, really bad. All right, so let's take a look and see if they have a demonstration on here. I just want to see if they've got something where I can do like a Mailjet demo site. Like, can we try one? Unfortunately, I'm guessing that I can't. Come on, folks. You must have a demo site somewhere, right? need to find a place where I can sign up for this, for like a mailing list, right? Don't you have a mailing list somewhere? Actually, don't they have a mailing list? Shouldn't a mailing list company have a mailing list I can sign up for? Here it is. All right. So let's suppose I want to sign up for this mailing list, right? Like, hey, I want to sign up for the MailJet newsletter, right? 1, 2, done, right? So now we know like how long that thing takes to go. I suppose I should have did that poorly. Let's try that one more time. I'm trying to think if there's some way I can make this trigger automatically. All right, here we go. So let's see where we actually hit this button, right? Trying to see if there's a good click somewhere here. Right there, I think. Here it is. User verify, right? All right. So we started clicking somewhere in here. See if I can get a better... That's the reCAPTCHA. So it's something, my count was about right. Seems like maybe. Hard to say. Try this one more time. I need to get a good, I want to have a good way of measuring how the performance is of this thing. So it's Control E. I assume Control E stops it too. Let's see. Ready? No, it doesn't. I really, really want to get a good performance thing of this here, right? There should be a way that says profile on click. You know what I'm saying to you? Like I'm going to click. Please record this. Control E just jumps up there. So you have to have the, it looks like you have to have the focus in here, which is not great. So that's mostly it. Like we've mostly got it here, right? So you can see here that it's about the 2 seconds that I thought, right? And you can see like everything that's going on there, right? I'm not sure how long it takes for the reCAPTCHA to work there. Is there any kind of event thing that I can look? Interactions. There we go. Mouse down. So you can see here, it's roughly the 2 seconds that I thought. That's perfect. That's what I wanted. There's the mouse down, right? And then we know that we get it right about there, right? So that's where we actually start. So we can drag back to the mouse down, which I think was right here. And this is the performance for their, website stuff. Now what's interesting about this is you notice it doesn't really work. So that's the first thing I can show you. Like, so now that I've said that. So there's an example of a mailing list site. And you could go to MailChimp as well, or some other sites and do it. So there's an example of a mailing list service. You'll notice it didn't even tell me that I was already subscribed, right? So it didn't tell me any information or anything when I put my my email address in there. So it really was just 2 seconds and then nothing happened. Like I don't even get confirmation other than just that I subscribed, but that's not true because obviously the second time I didn't also subscribe, right? So it's a bit weird. But anyway, so it's not great. It took 2 seconds. So then, let's go over here to hours or whatever, and let's just see how we compare, right? Like, did we do a good enough job to replace whatever the other thing was? So here's Casey, mollyrocket.com, record, subscribe. There we go. So let's see how our performance was, right? Where's our mouse down? Those are all mouse moves. There's the mouse down, right here. Right? Now let's take a look at where it was right there. Right there. Looks like the mouse down was right about there. You can see the subscribe button light up, maybe? Mouse down. Looks like it's right there. Right? So here's our actual time slider. You can see it's maybe about 300 milliseconds, I think. A little hard to say. So we're not quite 10 times faster, but we're over 5 times faster than their website is. And we actually know what happened, right? So we also tell you. There's a back-end demo, right? Record that. Show people, put this on a blog. Here, we timed how long it takes for the user response. Common sites take 2, 3, 4 seconds, maybe more. We take 200 milliseconds because our backend is awesome and we don't run 50 million lines of PHP code, right? Plus, we tell you our backend knows what's happening. Theirs doesn't, right? I don't know. So I think you can make arguments that, again, and just to be clear, you don't even have to necessarily be better. Like, the fact that we're way faster than them I think is cool because I like being better than people who aren't good at things. But the point is just that you looked into it. Like, you've demonstrated that you can analyze the performance of something. You know how long something could take. You have some ideas about why why something did or didn't work, right? You know how to investigate problems, whatever, right? Like, showing that you know how to dig into the technical details of something, that you understand the difference between your product and competitors' products, you know how to take assessments of different aspects of the package to see whether they're working. These things are things you can show you know how to do. You don't need a flashy website. I mean, I'm not really a front-end developer either, right? You can make flashier websites than this, to be sure, right? But the point is just, for the thing that you're working on, show you know how to investigate it, improve it, understand what's involved, show how to analyze other people's and yours and why are yours better or different, right? Or even just it's the same, but you knew to look at those features. Look, we are comparable to Mailjet's blah, right? Does that make sense? Have you read Out of Tar Pit? No, I have not. Have you checked out core.io, web server written in C? I have not. Apache is also written in C, is it not? I do use a C. I use a C-based web server internally for testing. It's called Mongoose. libmicro HTTPD is pretty good as far as I can tell. Oh, okay. Well, I'll have to check it out. Do you have any advice for a programmer having trouble to adjust to an OOP way of thinking on the job and how to cope with or handle patterns? Not really. Just understand what they are. They're people's ways of applying boilerplate code to a problem, right? So you just have to understand, it's the same as speaking a foreign language, right? If you go to France, you have to speak in French. When you're in an OOP code base, you have to understand their way of speaking. You don't have to think it's a good language, but you do have to understand how to speak it. What kind of projects would be interesting for recruiters to look at? For example, at the moment, I'm working on a 3D rasterizer and x86 assembly using mode 13 with a DOS simulator. Yeah, again, the project is probably not the interesting thing, because unless you're so good that you're going to make something that like no one else has ever made before, in which case, obviously you're going to get a job. It's not the project type that's important. It's what you show about what you knew and did, right? Put up some blog posts about you analyze it. If you're doing an x86 assembly mode 13 rasterizer, talk about the assembly. Why did you make certain choices? Show that you timed different ways of doing it. What turned out to be fast, what turned out to be slow under DOSBox. Do something that lets me know that you didn't just copy it out of Michael Abrash's book, right? But that's all, you just need to show that you are intellectually curious, you investigate things, you understand, you don't just copy and paste, you're not just searching Stack Exchange, right? Just give me what I need to understand that you know what you are doing. When you come to a problem and you spend time on it, you come away with an understanding of how it works and that you approach it logically and intelligently. That's just really all you need to show, because most programmers don't anymore. Not anymore, Uplink Coder, that's not technically a data breach, because it does not tell you anything about whether that person actually subscribed, right? They can't necessarily tell you if the person confirmed the thing, right? So I suppose that's true, right? But it's not a data breach because all it says is whether a particular email address is on or off the list, which you can add one yourself. So you have no idea who added it, right? But I agree that since MailJet does a thing where you're not considered on the list until you confirm the address, I suppose that is a data breach, because basically you're telling them whether they confirmed or not. Sort of. I mean, I don't know what to think about that, right? I'm pretty sure we are GDPR compliant. I read it very carefully, and it says as long as the person has shown interest, then you can mail them. And if you mail them, they have to be able to instantly unsubscribe, which they can, right? You do not need to add an unchecked by default checkbox. I challenge you to show me the place in the GDPR where it said that. I found no such thing. And I did not find anything that said double verification emails. Right? Because you're going to get one email either way. So the actual number of emails you send is not different. I do agree that maybe we should not tell you if the person has unsubscribed. Because unsubscribe is an action that the person takes that is verifiable to them. Like, If you unsubscribed, you had to have received an email at the address that has been entered, so that is technically information. Probably. So we should probably only say whether the email address has ever been entered into the form. So for example, if you unsubscribed, I don't know if there's I can't think of an address that's unsubscribed at the moment. But if you unsubscribe from the mailing list, we probably shouldn't tell anyone else that. Of course, then I'm not sure how that person... Here's a GDPR puzzle for you. How would that person ever get back on the mailing list? Because once they tell you that they don't want you to email them anymore, you can't email them. So if you don't tell them on the website, how would they ever actually get back on the mailing list? That's a little puzzle. That's a little puzzle, European Union. What's the answer to that question? I'm really interested to know now. Does anyone know? Because like what we do is if you enter the email address, it would tell you that it's unsubscribed, so you have to email us to say, right? But technically, now I think about it, we shouldn't do that. We should turn that off because it is telling you whether somebody unsubscribed. If somebody unsubscribed, we can't mail them, so if they put their address in here to try to resubscribe, we can't resubscribe them, can we? Because they told us never to email them. It just seems like, yeah, because, and that would be bad too, because then other people could just spam their email address in there, and they said they didn't want to hear from us, right? So I wouldn't really be comfortable doing that. Let's see what it says. Let's see. This link doesn't really say. My guess is like many things in the GDPR, it's underspecified. I don't know. Maybe we should write a blog post about it and then send it to the EU. Be like, hey, what do you do here? Right? If you unsubscribe from a mailing list, so you have a mailing list, and you don't want it to send any unnecessary emails. So you type in an email address, you hit subscribe. The only thing the person will receive is a mailing list email with an unsubscribe button on it, right? You don't want to say whether that person has ever accepted any emails from you, right? Because that would leak data, as pointed out before. So you just say whether an email address has ever been entered into the form, because that's meaningless. Anyone can enter anyone's email address into the form. You're not telling anyone anything, right? But someone unsubscribes from an email. Now you know that that person actually unsubscribed because the unsubscribe link has a unique cookie on it so that no one can unsubscribe you other than you, right? If someone hits that unsubscribe button, we can't send them emails anymore. But we also can't tell them that on the website potentially, because then someone else could enter their email address and find out that they're unsubscribed. Which, I don't know, maybe that's not a GDPR violation, but it certainly is at least a slight data leakage. So what would the GDPR prefer you do? Right? And I don't know. I mean, this is one of the problems with government regulations. They oftentimes aren't actually practically useful because the people who wrote them don't really know very much about what they're regulating a lot of the time. And they haven't thought it all the way through. So I don't know. They probably don't know, but maybe they do know. And if they do know, they could tell us and then we could comply with it. Whatever the opinion actually is. Maybe the answer is it should be exactly like it is now. Because, hey, knowing that someone else unsubscribed from an email address really doesn't tell you anything, right? If you have not previously unsubscribed... Wait, what? That wasn't on the link, was there? I didn't see that on the link. Let me see here. Oops, wrong keyboard. Yeah, that's not in there anywhere. If he unsubscribes, he has to accept the terms again, a checkbox when he enters the email address and wants to subscribe again. Yeah, but okay, so here's my opinion on that. Like, I disagree with that. Now, maybe the GDPR is just poorly constructed, but I think that's a really bad policy if that's true, because anybody can fill out a form and check that box, right? So if you don't have a one-click permanent unsubscribe, a griefer can just sit there resubscribing you all day long, and you'll just keep getting confirmation emails, right? A confirmation email is still an email, right? This is one of the things I think a lot of like regulations don't understand. A confirmation email is still an email. It's an email I didn't want, right? So I feel like once somebody subscribes to something or is subscribed to something, whether they did it or not, there should be a button you can push that blocks you from ever getting email from that people again, right? Vatterfowl, that is what we have, but if someone's trying to subscribe and they're not getting it, they may have forgotten that they unsubscribed or something. And so I wanted them to have some way of it telling you, here, email us. You know? You know what? Here's what we could do. Maybe this is the best solution. Maybe the right solution is just to make the response to any email address that has already been put on the list or unsubscribed the same. Because then you're not leaking any data. Then all you're saying is at some point in the past, somebody put this email address into this field. But you have no idea whether it was actually the person who did it, and you have no idea whether they're still subscribed. Maybe it just says, this email address was already entered into our system. Please email us if you would like to make changes. That doesn't leak any data. Right? I like that. I like that better. I'm going to change it to that. Regardless, I don't really care whether that's required by the GDP. It's just better. It's better to not leak information. So I'm just going to say that is what it is. Because that's the minimum amount of information leakage I could think of that still works and doesn't ever allow confirmation emails to just pile up by like a griefer. So I'm claiming that's the best solution. All right, I'm done for the day. Close it up. Okay. Thank you everyone for joining us for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always go to handmadehero.org and pre-order the game. It comes with the source code so that you can play around with it yourself and you can try things and do some experiments. We also have a mailing list you can sign up for, which we just showed a demo of. If you want to sign up for our mailing list, it's right there. We also have a Handmade Community Fund. You can check out. That's something that funds various things like our annotated episode guide or the Handmade Network forum, stuff like that. And it also comes with some fun stuff if you sign up for that, like that tab view app that I was using today, and a bunch of other things, old source code by me from the good old days. So check out that button. It's a pretty interesting thing to check. There's a little video on it as well. Also got a watch page, which is a thing where you can watch the series. It's got a Twitch viewer on it, but it also has a thing that shows the schedule, so you know when streams are going to be coming. And it's got a episode guide on it, which allows you to search the old episodes, which is pretty awesome. You can quickly get to old episodes. So that's pretty great, too, if you're trying to watch old versions of the series and you only want to look at things that pertain to a subject matter you're particularly interested in. Finally, click on the Handmade Hero head if you want to check out some of our other stuff at Molly Rocket. We got other cool projects in the works for you to explore. That's it for this weekend. I'll be back next weekend where we're going to have to finally wrestle with the tagging problem. We're going to have to decide how we're going to do that. Hopefully it's not that bad. Hopefully we're just like, hey, this looks good. This is how we want to do it. It's convenient. It lets us get our assets into the game quickly. Happy birthday. Maybe it'll be more of a struggle and we'll have to really fight tooth and nail to find something that we think works well and satisfies our other constraints. Only one way to find out. Come back here next week and we will see. Until then, thanks for joining me, everyone, and I'll see you on the internet.